I'm going to start tearing down this engine today. I've got it on the stand. I still have the whole harness on the engine. I need to get that off first, and then I'm going to start pulling the bigger parts off. Before I strip this thing completely down, I do want to get a weight on it. I'm kind of curious how heavy this engine is, and then later when I pull the engine out of my Tacoma, I also want to weigh that one to kind of have a comparison to see, is it heavier, is it lighter? I don't know. What do you think? I haven't looked it up. I don't know what these usually weigh dressed, full of fluid, versus the Toyota. We'll find out. The car is not totally done yet. I can't push this thing out of here yet because there's still other pieces that I need to take out of here. I've made that mistake in the past with other projects. I don't want to do that again. There's more harness that I want to take out of this car to marry with this harness so that I have some leads to pigtail into the truck. I also got to get things like the throttle pedal because this uses the electronic throttle pedal with the computer. And there's some other little bits and pieces. And honestly, if no one's going to buy anything off this car, I've done so many cars that I've tore down in the past. There's a lot of good stuff you can get out of them. Brand new bolts, a lot of hardware. If you got to go to the hardware store and buy, buckets of bolts, it adds up. So I'll spend an hour just picking good bolts out and save those. So I'm going to do that later. First, we're going to focus on the engine. So let's get into stripping this thing down and let's see how much it weighs. All right, the harness is off. There really wasn't a lot to take off. I know some people that are afraid of, modern cars and electrical freak out about all the sensors and stuff. But if you really look at what's here, there's not much going on. I mean, I could break down what all these connectors are because I've got them labeled, but it's not a big deal. Nothing to worry about. We're going to just put this over here for later use. This is my pile of things I'm trying to keep. For now. Anyways, I don't want to collect too much junk on this project. So I've got my cheap little crane scale. I've actually calibrated this thing before with weights, calibrated weights, and it's really accurate. So I've used it on a few things. I have not used it on anything this heavy yet. Like most women, I'm a little bit reluctant to reveal what she weighs, but you're going to see real time with me. I'm going to throw out a guess right now. This is mostly still fully dressed. I tried to leave most of the things on it that I'm probably going to run in the truck. Obviously, these engine mounts are going to be different, so I don't think I'm going to try to use these. I'll make custom ones, but it does have the engine mount still on it. Really, the only thing that's not on it is the harness. And I did pull the fuel filter bracket. There's not maybe a pound there. Not much. So it is drained, obviously, of fluids. So we're going to see what's going to weigh. I'm guessing, let's see. I'm going to say, I don't know, 285 pounds. Just going to throw that out there. Let's see what it is. I got to get it lifted on the scale, but I also need to remove the bracket to the stand. So give me a minute. Okay. All right, I'm ready. What the heck? That's way off. Really? Way off. Man, see, I'm a little bit sensitive of my weight. 168 pounds? No. Ha! See, scale. It's important. Hang on a minute. 168 kilograms. This is a, metric unit. Let's scroll through. I'm not good at conversions. Is that pounds? Newton? Oh, was it newtons? I don't know what the hell. Pounds. Okay. Wow. 371.04. We'll hear about that. 0.04. 370. What did I say? 285. Yeah, I was pretty far off, I guess. About 100 pounds. 100 pounds off. Yikes. Anyway, 371 pounds is what this weighs. So I will be pulling some more stuff off of this. Like the fuel filter, I don't plan to have it mounted to the engine. I'll probably mount that in the truck. So that'll be weight, total weight, but not on the engine. So But I am curious to see what the Tacoma engine weighs, but that's going to be a minute because I got a lot of stuff to do before then. But I just want to show you guys, I'm trying to touch it here. It's hanging. There's probably just a little bit of chain here, obviously. Look at that. What are we talking? I'm holding it, okay? It's extra bit of chain. It's going to be a stickler. 370. 371. Wham! No big deal. So, anyway, that stuff's off. I'm going to get back to getting on the stand and stripping some more things down. I stripped the block of most all accessories and brackets and things. We're down to basically just a long block. So I'm going to reweigh this thing to see how much weight we took off, because I'm curious what this little nugget weighs, what's left. There's not much else that I can take off of this engine when I transfer it into my truck. There's going to be some variables of things going back on, different manifolds, turbos, brackets, engine mounts. That stuff can change. But ultimately what's here, it's only going to get heavier from here, if that makes sense. So I'm just going to see what it weighs one more time, and then we'll go into some other details. Alright, what do we got? Hey, look at that. I don't know if you can see that. 200, I'm trying to touch it here. 263 pounds. Fool me the first time, not going to fool me the second. I learned my lesson there. And the weight of the chain right here, see? So I'm hanging out onto that. 261.46 pounds. That's what this long block weighs. Like I said before, most of this is going to be, I can't change what's here. I do have, because I pulled the tandem pump off, obviously got to run that with this. We'll set that on there too. 260, oh, 265 we'll call it. So that's what she weighs. Now I know that's what, close to my first guess. What did I say, 285 was what I thought this thing weighed with all the accessories. So that's, what was it? It was actually 370, I think, pounds before. So, wow, it's actually, yeah, like 100 pounds of stuff just sitting on the floor now over here. Before I pull this engine apart any further, I just want to talk about the injectors. I was able to get those out without any special tools. I've seen a few different DIY methods without a slide hammer tool. I don't have anything super special here in my shop for pulling these injectors, so I thought I'd just see what happens. Turns out that the old ladyfoot pry bar right here worked really well. So anybody that's trying to get these out without specialty tools, give it a try. I was going to machine my own slide hammer adapter tool if this didn't work, but it worked great. There's a webbing right underneath each injector. I kind of got them broke free with my basic pry bar, slipped this underneath, and they popped right out. 300,000 mile old injectors, easy peasy. No special tools, and super strong. Look at that. Anyway, next thing I need to do is check the camshaft to crankshaft correlation. I don't know anything about engines, but I did stay at Holiday Inn Express last night, so I'm going to give it my best. I have my degree wheel on the crankshaft. I have made a quick adapter now that the injector is out of number 1 cylinder. I can drop that down and touch the top of the piston. My degree, my indicator here is zeroed out, and I also zeroed out my pointer for TDC on number 1. So this is 100% accurate. Now I can find the intake and exhaust center line on the camshaft up top. This is just a 4-stroke diesel. Gas, diesel, doesn't matter. They operate the same way. I'm going to find out max lift on intake and exhaust currently as it's set up now. I'll write that down. I don't even know what the specs are from the factory. Everybody talks about special timing tools. Again, don't have any special tools. I just got this junk laying around. So we'll see what we get. I'll write it down. I can put this thing exactly where it was to the degree if I want to later. If I want to change it, I can do that too. I've used my degree wheel down here to figure out where the intake and exhaust camshaft lobe center lines are right now. So that way I can put it back exactly where it was because it runs fine the way it is. This cam gear is adjustable. It has slotted holes with these bolts, and you can change that relationship to the cam to crank. Now, they like to call this the torsion value with the computers and the software. So later on, when I do get the software for my laptop and I start putting this in my truck, I'll be able to fine tune all those settings to make all that happy. But at this point, I was able to at least measure the center lines and also go through with my indicator and measure the lift of all the valves and the injectors. So as far as I can tell, looks like a healthy lobe is around 350 thousandths of lift. And unfortunately, number 1 exhaust and number 4 exhaust have about 28 thousandths of wear. So that's no good. Number 2 exhaust as well has about 6 thousandths wear. I do plan to install a new camshaft anyways in this engine, as well as go through this entire head. I want to rebuild it, and I want to clean out, there's like lots of carbon buildup in the intake ports. I want to get this thing cleaned and ported, new camshaft, freshen up all the valves, just get this thing good to go later on. I went ahead and measured these injector lobes just to see their lift, the duration, all that stuff. I got all that written down, just my own curiosity. These ones are around 293 thousandths of lift on those, and they're all within about a thou of each other. So gotta like those roller tips. That's the preferred application, you know, for camshafts. So most are roller. You don't see a lot of flat tapping stuff anymore, but I've got all this written down so I can start tearing this apart, getting the belt off, get the head off, and I really can't wait to see what's in the lower end. I hope everything looks good down there. I heard these are pretty beefy, and that's kind of one of the reasons that I was leaning towards using this block. So let's dig into it. Camshaft's out. I went ahead and wiped off most of that black diesel oil so you can get a better look at everything. I want to know what the heck's going on in here. You can see the copper showing through on some of these camshaft bearing shells. Don't like that. Although, if I pop one of these out, you'll notice it's got a window kind of machined in it. I don't know. I thought, you know, these are original. I thought that was kind of an aftermarket thing or a later revision. I feel like maybe somebody swapped these out at some point. But these lifter buckets down here definitely are not the upgraded black nitride. I couldn't really tell before, but that's just the basic steel ones. They are kind of worn in, so that's not great. I almost wonder if somebody put it, because that cam looks really good. Mostly. It looks newer to me. I'm wondering if somebody either put cam bearings in it with like the upgraded oiling and then just put the standard buckets in, or maybe they didn't put new buckets in at all, which would be a terrible idea. I don't really know, but let's take a look at the cam and the other shells. These upper caps look amazing. They looks like they came off a different engine. They're so nice. There's really hardly any wear at all. They almost look new, except for number 4 here. There's a spot right here where it just started to go through a tiny bit of the outer coating. Other than that, they look great. These also have the slot in them for the oiling. But I thought I saw something where the trick with this whole slot is that you need to drill into this small oil feed hole so that you can get extra oil up to this bearing. That hasn't been done. So again, don't know if these are original aftermarket bearings. Somebody didn't do the full job. But here's the camshaft. Honestly, looks like a pretty nice cam. It's got a FP something number on it. I don't know what that is. I'll try and look that up. But every surface is polished or ground. It looks really nice. I swear, the ones that aren't worn almost looks like it's a fresh grind, like it's a newer cam. And it looks pretty great. So unfortunately, I'm not going to be using it, but I'd like to know more about it. I'm just going to set it aside and get to pulling the cylinder head next. Okay, time for the big moment. Oh wow, that just jumped off of there. Okay, there it is. Oh, look at those little pistons in there. Got some bowls of diesel fuel. Oh, the dowel came right out with the head. Not a lot of carbon buildup like I thought would be in there. Doesn't look too bad. I don't see any valves that aren't jiving. They all look pretty happy. They're all flat. Okay, let's get this head out of the way. I swear I heard something drop. Was that a washer? Yeah, I don't know. Maybe it was nothing. Here's the head gasket. Oh yeah, that's down there. Definitely wasn't leaking. Got a good seal around all these. What's this? The ALH. Okay, this is a 2-hole. I know that there's head gaskets with different hole numbers in them. It says 2 holes here. Pull that off. And there's a deck surface. You can see that it's sealing really well. Yep, looks good. Don't see anything too out of place. There's no piston to valve contact that I can see. No cracks. Let's see if I bring these up a little bit more even. All the fuel bowls, well, they're combustion bowls in the piston. They're full of fuel now, so I'm going to call them fuel bowls. Little combustion pockets in here. They're full of fuel that drip down when I pull the injectors out. There's a little bit of shiny metallic in there. I think that's just junk that was, around that pocket of the injector. And when I pulled it out, the diesel just kind of flushed it down in there. I don't know. I don't know what else that would be. Just little tiny, small bits of metallic. So otherwise, it looks pretty good. I want to get a indicator on this and check piston to deck height just to see, make sure I don't have any bent rods or pounded out bearings, just so I can write those numbers down while I got it in the state. And then I want to flip it over and get that pan off. I'm really curious to see what's going on down there. I got the deck surface cleaned up. Also, all the tops of the pistons have been cleaned up, so they're flat. Now I can get a more accurate measurement of the piston to deck height. This indicator has been zeroed out. It's sitting here on its magnetic base. I'm just going to rotate it in just enough now to touch the top of the piston, and then bring it all the way up to TDC. Stopping right, yeah, it's starting to go the other way. 22 thousandths above the deck. Let's see here. It's going to be rocking the piston though. So you got 28 and 14. 4 and 8's 12. So yeah, right? About 22. I think we're at. Yeah, right. 21, 22 thou, I believe, is what we got. Let's do a zero check. Back at 0. Well, the truth hurts sometimes, and I thought to my eyeball, the old eyeball micrometer, that number 1 looked a little bit lower. I was going to say about 10 thou. It measured 22 out of the hole. The rest were right around 40 thou. So something's going on with this piston, because it's, well, not necessarily the piston, but something in the cylinder. So could have a bent rod, could have a pounded out bearing. I'm not really sure. I'm going to need to tear it down further and see why, but that explains why this cylinder was slightly lower on compression. When I originally did my compression test, these were all around 450. This one is around 420, 430 PSI, so a slight difference, and it shows. So it's what it is. We'll see what I can find out next. Ooh, look at that mess. Wow, German engineering. That looks like it's going to add some weight to this sucker. This is the balance shaft module, the BSM. It's a monster. Look under here. Oh, there's a crank trigger right here. All right. Can't see much of the lower end, honestly, until I get this sucker off. Bunch more triple squares. I got to get the timing chain off of here first. Drives all this stuff. I can see the pickup screen's clean. There's no debris down here. I don't see any like metal shavings or anything. So I don't know. Let's get this off now and see where that leads to. Wow, that thing is, that's pretty heavy. You know, I said I was trying to reduce some weight off this engine. I think this balance shaft module is probably going to save me another 15 pounds or so. This sucker's got some weight to it. Look at the underneath. I know on these, so the idea is that it's going to help balance the harmonic, vibrations of the engine, try to smooth it out. You can see the counter shafts in here spinning. There's a gear-to-gear under this part. There's a chain that drives this hub. And also, see, that hub drives this shaft, this gear drives this one. These are paired up, and then they kind of whoop around this side. There's a hex keyed shaft right here, and I've heard the big downfall of this is that shaft will shuck around, beat itself up, and eventually it just kind of free spins and doesn't drive this oil pump at all. You lose oil pressure, things go downhill. I can actually see this one's still engaging, but there is quite a bit of slop on both sides. So, this does appear to be untouched down here. So 300,000 miles, this thing was still living on. That's another good sign that, this was at least taken care of. But I need to dig deeper now into these rod bearings and see, and maybe get these out, these piston rod assemblies. Maybe I'll see something why number 1 looks a little shorter. Let's go. I got the piston and rod assemblies stripped out of this block. For now, the crankshaft's going to stay in there. I don't have any need to take it out yet. You can see this thing just spins over so smooth. No hang-ups. Really happy about that. And then those rod journals, man, they look really good. They're like mirror polish still. No scoring, scratching, any of that kind of stuff. The thrust bearing has very minimal thrust. These piston rod assemblies, however, I need to break these down further and take some more measurements to find out what my piston protrusion issue was. So I'm going to get to that next and see what I find. Starting with flatness, I'm going to set one of these carefully on my surface plate and treat this thing like royalty. No rock in it. If there's no rock on that side, I'm sure there's no rock on that side. So we're going to go through all these. About 26 millimeter is what we got for wrist pin. I'm just going to turn this thing on its side. I'm going to measure from the top of this bushing to the top of the piston. And I have 1 inch, 294 thousandths. And I guess for the metric speaking folk, that's right around, come on, 32.85. So I'm going to measure that on all these pistons, and we'll write that down next. The last thing I'm going to measure here is going to be the connecting rod length. So I know that the wrist pin is 26 millimeter. Now I need to measure the rod journal. It's just going to be easier to do that. So I'll get that number, and then I'm going to measure from here to here, the top of each, well, I guess it depends on how you want to look at it. I'm going to measure along this beam. So I need to measure from the bottom, I guess you'd say, of this bushing to the top of where this bearing is, and then I'll get that length and write all those down. Results are in, as you can see, in my highly skilled drawing here. You know, I'm not trying to go for art prize of the year or anything like that, but I did want to just, I drew this out so I could write my measurements down. Anybody that doesn't quite know this procedure, this might be a little bit of a visual aid. So what I was after was measuring compression height of the piston. So you're looking through the center line of the wrist pin to the top crown of the piston here. So that measurement, when I checked it on all these pistons that I pulled out, exactly the same. We're all good there. So they're all at 1 inch 805. Fine. Crankshaft stroke, I didn't even measure it because I really didn't see that being an issue. That'd be a really bummer thing to happen if one rod journal was either worn or offset ground improperly. So didn't even measure the stroke, but that could contribute to a piston protrusion issue. Since I knew that the pistons were okay, that really pointed toward just having a bad rod. So measured all the rods. So I have my rod length is going to be center line of the wrist pin, center line of the rod journal down here on the crankshaft. So I measured the wrist pin diameter and I measured the crank pin diameter. So those measurements are here. And then I measured the beam length, which is from basically the bottom of this wrist pin bore to the top of the rod journal bore here. And right away, I started going through my measurements and I had an anomaly. Look at this one here, 4 inch 140. The rest, 4 inch 158. Knew right away, 18 thousandths shorter, which is exactly how much shorter the protrusion of my number one piston was. So there you go. That is the problem. This rod is slightly bent. Can't really make it out. So just to confirm that it's not a manufacturing error, but it is in fact a bent rod, even slight as it is, I went ahead and set it up in my CNC mill, and I used my DRO and touch probe, and I was able to map the known good rods in a quick fixture and see that the bend, actually I put a little plus sign on it, it's actually bent this way just slightly 18th thou on this rod. So I'm after a good used rod. I don't have any reason to buy any super high performance aftermarket rods. I'm not going super duper crazy with this build. These are supposed to be super stout. I think I'm going to try to locate a good used one. Hopefully I can find one so I can start getting all the parts that I need to put this back together. So I'll make my list for building this back up. And while I'm waiting for those parts, I'm going to start tearing down the Passat. I'm going to get the fuel pump, the throttle pedal, extra wiring, any other little bits and pieces that I might think I need for the swap out of that car so I can get that the heck out of my garage. And that'll be all in the next video. We'll see you then.